Hello everyone, my name is Mohamed. I am a Java developer. In this video, I'm gonna lay out a possible strategy to help migrate your existing Java code to Java 17. As we know, Java 17 is the latest long-term support version released back in September of 2021 and offering several new features since the previous LTS version, which was Java 11. Two of the most interesting features of Java 17 are Java records and Java sealed classes and interfaces. We will focus only on these two and show how you can gradually start migrating your old code to use these new features with the help of Froporec and Jisel libraries. Let's start with Java record classes. Those were introduced in Java 14 and finalized in Java 16. One of the main motivations behind the Java record classes is to reduce the amount of code we write while defining or using data objects in Java. Additionally, with records, you can make your data immutable, which is very helpful if you want to ensure data security and consistency in your code. To define a new record in your code, you will just go ahead and do something as simple as writing record, the name of the record, and here you will just list the attributes of the data object. So let's say we have the ID attribute and maybe name attribute, and let's add the third attribute here, just like this, and you will just close it like this, and that's it. Quick and clean to do. Also, instantiating a record class is as simple as calling the default generated constructor, also called canonical constructor, just like this. So let's say we add the main method here. So we'll just go ahead and define an instance of our record class like this. And here we only have to list the value of each one of the attributes. So for the ID, for example, of 1, and the name, and for the long attribute, let's say 12. And this is it, you have the instance of your data object record created right there. And then you can access each attribute through the generated accessors method. As you can see here, we have the name method, ID method, data attribute method, which allows you to access the value which you entered here. And that's it for a very basic use of Java records. Now, Java has been around for over 20 years before coming up with the new concept of record classes. So there are tons of projects out there with hundreds or even thousands of data objects defined as plain old Java objects, also known as POJOs. So having to manually rewrite all of those POJO classes into record classes is something possible, but will be very time consuming. And this is where Froporec library comes up. Froporec provides annotations which can be used on your existing POJO classes. Once you apply the annotations and run your project's compilation, Froporec then generates a record class for each one of the POJO classes which you annotated. Here, for example, we have the person POJO class, which belongs to the data1 subpackage of the client package. We then annotate person with record, and once we run the compilation, here you will have the generated sources folder containing the person record class generated under the same subpackage as the POJO class. If we then go to our previous business logic and then we type person, as you can see, we now also have access to the generated person record class, which can be used in your code just like any typical record class. So for example here, let's create person record equal new person record, and this constructor takes in the parameters of the person POJO class, which are in this case last name and age. So that will be, and that's it. Another interesting feature offered by Froporec is the generation of a custom constructor, which can receive an instance of the existing POJO class. So in case you have some existing business logic already processed an instance of person project class. Let's say, for example, you have person. Let's call it person project. And then you have, so you can now create a new person record and instantiate it like this. And then by calling the record accessors method, you will have the same data as the one stored in the project instance. So that's basically it with Froporec. More interesting features are offered by Froporec, such as making a record object fully immutable, or the possibility of combining fields from many different project classes into one generated record. We will leave those advanced features out of this presentation. So this was the first step in migrating your code to Java 17. And it was essentially about turning your existing project classes into record classes. Now, the next step is about integrating the new concept of Java sealed classes and interfaces into your existing code. Sealed classes and interfaces were introduced in Java 15 and finalized in Java 17. The main goal of the sealing mechanism is to allow a stricter control over inheritance in Java. And to achieve that, you will have to follow a set of rules. Let's explain this better with some code. In Java, we will typically express inheritance as, for example, child class, extend parent class, implement parent interface. Let's quickly create the parent class and the parent interface. Now, the purpose of the sealed classes and interfaces is to allow restricting the extension or the implementation of a class or interface. So if we seal this interface here, we will now be required to define a list of child classes or child interfaces which can implement or extend the interface. We will do so by using the permits keyword and specifying our child class here. Now, despite doing that, you can see we still have a compiled error, and this is because the sealing mechanism in Java is so strict that it requires that any member who extends or implements a sealed class or interface must be either final, sealed, or non-sealed. Here we will choose to make it final, and now you can see that all the compiled errors are gone. This is compiling fine because we added the child class to the permit list. Let's say we create another class here named, for example, test class. We make it final, and instead of child class here, we specify only test class. If we then go back to the child class, you will see now we have a compile error saying child class is not allowed in the sealed hierarchy. So for this to work, child class definitely has to be part of the permit list. Now you can see child class is no longer showing the compile error. And this is how strict the hierarchy sealing mechanism is in Java 17. Now let's talk about our migration strategy using Jisel library. The main purpose of Jisel is to apply the interface segregation principle while combining this process with the sealing mechanism of Java 17. Now, the truth is, you are not always required to segregate your interfaces when you use Jisel. Jisel can also be used only to generate the sealed version of an existing interface while simulating an actual interface segregation. And of course, doing so can also serve as a starting point for applying the segregation principle to your code sometime in the future. Just like Froporec, Jisel also offers some annotations which you can use on your existing code. In the sample code provided in Jisel GitHub repository, we have this interface named the processor, where we apply Jisel's annotations such as top level and seal4. If you look at the intended result on this diagram, you will see that we are expecting to generate all these smaller sealed interfaces you see here, while there will always be a top-level parent sealed interface generated. As you can see, the only abstract method which the top-level sealed interface will have in this example is process object, which is why the top-level annotation is used only on this method here. Now, instead of using the top-level and seal for annotations, we will only use the top-level annotation on all abstract methods like this. So the result of this when we run the compilation will be, instead of having smaller sealed interfaces generated as we saw on the UML diagram, we now only have one interface, which is the top-level parent sealed interface, and which has all the abstract method we saw in the annotated processor large interface. As we mentioned regarding the rules of sealing in Java, a sealed class or interface must necessarily specify the leads of its child types. In our case, here in this example, we've just started migrating our interface. And because we haven't defined a child type for the generated sealed interface yet, Jisel will automatically generate a convenience child class named the underscore processor final class and adds it to the permits list, as you can see here. If you go to the generated final class itself, it's just a pretty useless class, only providing default return values for each abstract method. Later, we will see that once we start specifying child types for this generated sealed interface, this permit list will be automatically updated by Jisel. Besides the generated sealed interface and the convenience final class, you will notice we also have a report text file. This text file simply lists all the generated sealed interfaces, and for each one of them also lists the child types. As we've just mentioned, so far the underscore processor final class is the only child type implementing the generated sealed processor interface. Alright, we've just achieved the generation of the sealed version of our old Java interface, the processor interface. And now let's see how the existing child types, which are making use of the processor interface, can be migrated to make them implement or extend the generated sealed interface of processor. Before we continue, let's describe the context a little bit here. Let's say you are part of a development environment where there are three teams: Dev Team 1, Dev Team 2, and Dev Team 3. In each dev team, we have a set of classes or interfaces implementing or extending the processor interface provided by the lead developer. Here we created only one child type for each team. We have Team 1 child class implementing processor, same with Team 2 processing implementation, and the third child type, which instead of being a class is an interface extending the processor interface. The goal here is to make each one of these three child types implement or extend the generated sealed processor interface instead of the original processor interface. If we go to Team 1 child class and simply come here and type sealed, you can see we indeed have access to the generated sealed processor interface, which we then select to replace processor as the implemented type. As we mentioned before regarding the sealing rule in Java, the child type must be either final, sealed, or non-sealed. So a very simple way to handle that rule while migrating your code is, if the class you are working on is not being extended by any other class in your project, then you can just go ahead and make it final. Now, as you see, we have the non-compiled error complaining that the child class should be part of the permits list of sealed processor, which of course is not the case because it was generated only with the processor final class as the child type. You might think of just manually modifying the list here, but remember that whenever you run your project compilation, this sealed interface will be deleted and regenerated. So whatever manual change you make here will simply be lost. Instead, you should let Jisel generate the correct permits list for you. To do so, you will need to use the add to annotation on top of the child type you are working on. The add to annotation takes two arguments, one named profiles, which is a non-mandatory array of string values, to be used only if you are performing the interface segregation process with Jisel. The other argument, which is mandatory, is the large interface class value, and in our case, this will be processor.class. And that's it about the use of the add to annotation. Now, we are still seeing the compile error here, which means our team1 child class still hasn't been added to the permits list here. And that's simply because we haven't compiled our project yet. So let's do that quickly. And once compilation completes and you get back to the editor, the compilation error magically goes away. Now let's look at our generated seed processor interface again. And you can see the permits list no longer refers to the convenience file class we previously saw, but now only lists our team1 child class where we use the add to annotation. The same process will be applied to the two other child types we have here. Team2 processor implementation will follow the same pattern as team1 child class. And with team3 child interface, there will be a slight difference with the correct modifier to use here. As we know, in Java, we cannot make an interface final. So in this case, because we haven't sealed this child interface yet, the appropriate modifier will be non-sealed. Now let's go ahead and run the compilation once again and see the permit list of sealed processor now has all three child types. And now our test report also lists all three child types on the seed processor. You can see how helpful this test report could be for the lead developer of the project, who can just come here and see which child type from which development teams is implementing or extending the sealed interfaces generated with Jisel. And that was it about how to apply Jisel to your project. Here is a quick summary of each tool we've just presented. The common requirements for both libraries is to run your development project under a minimum of JDK 17.01. When it comes to specific requirements, for Froporec to work as expected, you have to make sure your annotated classes have getters. If a getter method is not found for an attribute of the class, then that attribute will simply be ignored while the source code of the record class is being generated. You will also see that Froporec provides some annotations which can be applied on existing record classes and not only on Pojo classes. In that case, the require getters rule doesn't apply. Also, nowadays, we have many popular third-party libraries such as Lombok, which can generate the getters and setters without the developer having to write them all manually. It's absolutely fine to use those libraries besides Froporec. They integrate very well without any problem. With Jisel, so far the only known requirements will be to modularize your Java project so that you will be less restricted while making use of the generated sealed types. You can still run Jisel without any Java module in your project, but then for the child types to access their sealed parent types, they will all have to be part of the same Java package. The execution runs at compile time for both tools. and in both cases, the generated types sit next to the annotated ones. So far, there's already been a couple of versions released for each library, and we recommend to use the latest ones. And to conclude, both Froporec and Jisel are fully compatible with all current and upcoming versions of Java since Java 17. The concept of records and sealed types are here to stay. They are not being removed from Java anytime soon. Instead, there will be improvements to those features, and we will keep Froporec and Jisel updated as much as possible to reflect the latest changes. One last word of personal advice is, it's time to migrate to Java 17. Whether with the use of Froporec and Jisel libraries or using any other ways, it's time to consider migrating your project's JDK, code base, and also your developer's knowledge to Java 17. There are several projects out there still running on the older versions of Java, such as Java 5, 6, 7, and mostly Java 8. I will recommend migrating these projects straight to Java 17. And even if your projects are already running on Java 11, you will still benefit a lot from migrating to Java 17. This strong recommendation is for a few considerable reasons. Besides the use of record classes and sealed classes and interfaces, Java 17 also offers several new features which help you express your solutions designs and implementations in a more modern way. If you go through all the new features introduced since Java 11, you will find out they are more adapted to the current needs we see today in whether cloud computing or AI, machine learning, and so on. Another reason why you should consider migrating to Java 17 is the widespread use of Spring Framework and Spring Boot. Starting from Spring Framework version 6 and Spring Boot version 3, these very popular enterprise frameworks will require a minimum of JDK 17 at runtime. And we shouldn't be surprised if many other frameworks or libraries follow the same pattern. One last thing to consider is, at this moment, as we are speaking, Java 17 has been out for over a year now as the latest LTS version, while the non-LTS versions, Java 18 and 19, are already available. And the next LTS version, which is Java 21, will be out sometime in September of 2023. And as we know it, many new interesting features will be added to Java 21 on top of Java 17 features. So, migrating to Java 17 now and gradually updating your developer's knowledge will help reduce the effort when the time comes to move to Java 21. And that's it for this presentation. Feel free to visit Froporec and Jisel websites. These are hosted on GitHub. They are essentially technical documentations with links to code samples and the GitHub repository. There you can access the source code or report bugs. You can also check my portfolio website to find out when we release a new version of any of these tools. We are currently working on minor bug fixes, also defining new requirements for upcoming versions of Froporec and Jisel. So that's it. Thank you for watching and happy migration.